Example 1 here on the chain rule is taking a look at using the chain rule. So we've got our function f of x here, and we just want to find the derivative of f of x with respect to x. So the first thing we should do here is denote that g of u is equal to the square root of u. And u here is equal to h of x, and h of x is equal to everything underneath the square root. So that's 2x minus 1 over x squared. Okay, so we can write then f of x as g of h of x, like so. So what we need to do now is find the derivative of g of u with respect to u, and then we will also need to find the derivative of h of x with respect to x. So first, let's start with the derivative of g of u with respect to u. So here, we could write this as u to the power of a half. If we differentiate this, we get 1 over 2 times the square root of u. Okay, and if we substitute now u equals 2x minus 1 over x squared back into this expression here, we obtain 1 over 2 lots of the square root of 2x minus 1 over x squared. Okay, what we need to find now is du by dx, which we can write as the derivative of h of x with respect to x. So we find dh, or derivative of h of x with respect to x here. Well, that's simply going to be the derivative of 2x minus 1 over x squared with respect to x. That will give us 2 plus 2 over x cubed there. Okay, which we could write, if we prefer, as 2x cubed. So 2x cubed plus 2 all over x cubed if you prefer. And all we need to do now is multiply these two, which would give us the derivative of f of x with respect to x. So therefore, if we clear everything and do that, what we obtain then is a derivative of f of x with respect to x, and that's equal to 2x cubed plus 2 all over x cubed times by 1 over 2 lots of the square root 2x minus 1 over x squared. Okay, so that's 1 over x squared. And if we simplify here, what we obtain is x cubed plus 1 all over x cubed times the square root of 2x minus 1 over x squared there. Okay, and that gives us the derivative of f of x with respect to x. Example 2 here on the chain rule is taking a look at connecting rates of change. So we're told the surface area of a cube of width x centimeters, length 2x centimeters, and height 4x centimeters decreases at a constant rate. And we're asked to find dx by dt at the point where x equals 5 centimeters. So to start with, let's calculate the surface area of this cuboid. And to do that, let's say A here is equal to 2 lots of x times 2x plus another 2 lots of x times 4x, and then finally another 2 lots of 2x times 4x. Okay, so that would give us the total surface area there. Okay, so here now all we need to do is expand these brackets and collect like terms, and if we do that correctly, we get 28x squared here. Okay, so 28x squared. So using this surface area now, what I can find straight away is the derivative of the surface area with respect to x. Okay, so that would be dA by dx. And in that case, that's simply going to be the derivative of 28x squared with respect to x. And in that case, that would simply give us 56x there. Now we know a decreases at a constant rate. So in that case, we can write now that dA by dt is equal to this constant rate. And the constant rate here, well, this is a decrease, so we write this as minus 0.07 there. Okay, so just be slightly careful for that. It's a decrease, so make sure we denote that that's negative. Okay. So now we use the chain rule to find dx by dt. And if we know here the chain rule, dx by dt, well, that's simply equal to dx by dA. We times this by dA over dt. Okay, but we can also write this as 1 over dA by dx times by dA over dt. Okay, so remember dx over dA, we can write that as 1 over dA by dx. So in that case, we can write this as 1 over 56x, remember dA by dx, 56x, so 1 over 56x, times by dA by dt, which we know is minus 0.07, times by minus 0.07 there. Okay, so in that case then, we can write this, if we just clear this first, just so we've got enough room here, well, that means we can write this then as being equal to minus 0.00125 over x. Okay, so this is for dx by dt, so this is dx by dt. Okay, but remember, we want to find out now dx by dt at the point where x equals 5 centimeters. So when x equals 5, so therefore when x equals 5, well, in that case, dx by dt is equal to this value here. So all I need to do now is just replace x with 5. In that case, dx by dt when x equals 5, well, that would give us minus 0.00125 divided by 5 there. Okay, and if we calculate that here, that'll give us minus 0.00025 there. And don't forget our units here, we just note those down here. Okay, and that gives us the solution to example 2 there on the chain rule.